Today's video will be on enlargement and similar figures. So our learning goals for today: by the end of the lesson you'll be able to enlarge figures using given scales, find the scale factor, use the scale factor to find variables, prove pairs of triangles are similar, and find missing lengths using similarity. Okay, so key ideas. So enlargement is the transformation which involves the increase or decrease in the size of an object. So let's say I had a square here. So let's pretend it's a square. So enlargement is obviously going to be the transformation, so we can make it larger. Whoa, let's pretend that's not there. So enlarge it, so it's still the same shape, so it's still a square, it's just larger, or we could also make it smaller. So it's still the same shape, it's still a square, but it's smaller. So the size of the object must stay unchanged, and enlargement uses a center of enlargement and an enlargement factor or a scale factor. So our center of enlargement is usually an O point here, which each of the different corners of our shape will hit. It'll become more clear as we move on through this. So the scale factor, we've got a formula there. So your scale factor is your image length over your original length. So in the diagram down the bottom, our original would be the smaller one, and that the values of that become the denominator, and the image is the large one in this instance, and that would become the numerator. So for instance, our value from A to C, could be X, and our value from A dash C dash in our image would be Y. So if we put that into our scale factor, our image length would be Y over X for that part there. And we could use that to find what our scale factor is. So if we work out that scale factor and we get an answer between 0 and 1, the image will be smaller than the original, which in this case of our example that wouldn't happen because obviously our image is larger than our original. So if the scale factor is greater than 1, which is what we would have in that example, then the image will be larger than the original. And if the scale factor equals 1, then the images are actually congruent to each other, because obviously if it's 1 to 1, they're exactly the same, so they're congruent images. Okay, so similarity. So two figures are similar if one can be enlarged to be congruent to the other. So in this example, if we were able to stretch out this one on the left here and make it bigger, we would actually get this shape on the right. So even though they're similar figures, because if we could stretch the one on the left to make it bigger, it would be congruent to the one on the right and turn into exactly the same shape. So all the corresponding angles in similar figures are equal. So you can see 100 degrees, 100 degrees, 140 degrees, 140 degrees, 80 degrees, 80 degrees, 40 degrees, 40 degrees. So even though the sizes of the sides of the shape are different, the angles are always equal if they're similar figures. So pairs of corresponding sides are in the same proportion or ratio. So for instance, A to B and E to F, we've got our scale factor here. So this was our original and this was our image. So we've done our image over our original, so that was E to F over A to B, and that's 10 over 2, which gives us an answer of 2, so our scale factor is 2. So our image is twice as big as our original. So the symbols 1, 2, 3 vertical lines, or like a little wavy line are used to describe similarity. So remember, congruence was like an equal signs with an extra line. That's not what we use for similarity. It's kind of flipped the other way. So for similarity, it's 3 vertical lines or a little wavy line. So if we were writing about these shapes here, we would say that ABCD is similar to EFG. So ABCD is a similar shape to EFGH. As I said, you could also use the wiggly line if you prefer. So again, the letters are usually written down in matching order. So just like they were for congruent shapes, they're written in the same order. So A corresponds with E, B corresponds with F, C corresponds with G, and D corresponds with H. So that's just the way we write things. Okay, so we've got a worked example here. So using the given center of enlargement, O, so that's this point here, draw a similar figure to triangle ABC to the scale factor of 1/2. So what we do is we grab our ruler, which let's see where mine is. Again, this is hard for me on this, on the drawing pad I'm using to draw straight lines. That's not going to work. So you use your ruler and you connect to O all of the points using a straight line. Let's try again. So you'll use your ruler, connect all of your points. Now my pen's white. There we go. So that didn't work, but you would have a ruler. From there, our scale factor is a half. So what we are doing is we're going to measure halfway along there. So in this case, on my screen, I'm not sure how big it is on yours, it's about 5.5 centimeters. So it'll be 2.75, that would be there. And that would be C dash. For B, it's about 4 centimeters, so 2 would be here, which is B dash. And the last one, A, is 6.5 centimeters away, so it would be 3 bit, which is here. That would be A dash. Then you could just join all of these together again with your ruler. Let's put A dash down here, and you'd have, you've enlarged the figure using the scale factor 1/2. So you're drawing from each of the points of your original. So this is my original, this is my image. So you're connecting each of the points A, B, and C with a straight line to our enlargement, which is O. And then halfway along those lines, you're putting a dot. We know it's half because we're given a scale factor of a half. Halfway along, you're doing a dot for each of those points, connecting them up, and that's one way that you can use enlargement to create similar figures. Okay, so another worked example, complete the following for the similar figures shown. So this time they've told us that they are similar figures. So find the scale factor. So for A, we have to do scale factor. And scale factor is our image divided by our original. So in this case, we do have some values for the image and the original, but we also have some missing values. So the only one that we've got corresponding values for is the kind of like the flat base here. So on our image, we've got 6 centimeters, and on our original, it's 4 centimeters. So I'm using these because we've got actual values, not variables for each of those. So it'll be 6 over 4, which is 1.5. So our scale factor for this one is 1.5. From there, we can do B. So find the value of X. So X is this side. I'm actually going to change to a purple pen so it shows up a bit more. So X is this side on our image, which actually corresponds to this side on our original. So we know that our image is 1.5 times bigger than our original. To find X, we're going to have to multiply. So X equals 3 centimeters on the original times by 1.5, because it corresponds to that side there, but it's 1.5 times bigger. So you're just going to do 3 times 1.5, and you'll get 4.5 centimeters. So X is 4.5 centimeters. And then for C, you have to find the value of Y. I'm going to have to clear my screen. Obviously, you just keep working down the page. So for C, we have to find the value of Y. Now, Y is this unknown side here, and it corresponds to this side here of our image. So in our image, it's 7.5 centimeters, and we know that our image is 1.5 times bigger than our original. So to find Y, we're going to have to do 7.5 divided by 1.5, and that will give us a value of Y, which I think is 5. So 7.5 divided by 1.5, yep, equals 5. So we know that Y has to equal 5 centimeters because we're using our scale factor there. Okay. So some more key ideas. This time we're looking at similar triangles. So on the right here I've got an example. It's not drawn to scale, but they are similar triangles. So two triangles are similar if the corresponding angles are equal. So obviously both of these have right angles, so they're both going to be equal. They're both going to be 90 degrees there. Then we've got an angle here, and that would have to be equal to this angle here. And this angle here would have to be equal to this angle here. So all the angles would have to be equal. So the corresponding sides also have to be in proportion, so in the same ratio. So for instance, side AB over side DE, so that's 3 over 6 is divided by 6. Don't know why I had to use a calculator for that, mind blank, 0.5, and it would be the same for the other sides. So that would be the same as, so let's go BC C over FE, that's 5 over 10 equals 1 over 5, which is 0.5. So you can see that all of our sides are in the same ratio. So all our angles are equal and all our sides are in the same ratio. So this means those two triangles are similar. So the similarity statement for two triangles is written the same as we do for any other figures. So triangle, A, B, C is similar, which is those vertical lines to triangle D, E, and F. Alternatively, you can use that wavy line as well. And again, we are trying to write those letters in matching order. Okay, so we actually have some tests that we can use to test for similar triangles. So these tests are actually different to the congruent tests. So these tests are SSS, so side, side, side. So all three pairs of corresponding sides are in the same ratio. So you can see this side and this side are in the same ratio as this side and this side, this side and this side. So our triangle on the right is just twice as big as our triangle on the left. Our next test is side, angle, side. So two pairs of corresponding sides are in the same ratio and the included angle is equal. So you can see here our angles are equal, and this side are in the same ratio as this side to this side. So this one is 22 over 11, and that's equal to 10 over 5. So they're in the same kind of ratio, because if we were to simplify that, that'd be 2 over 1, and that equals 2 over 1 as well. So they're in the same ratio and they've got the same angle in between them. Okay, so the other test we can use is angle, 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 or just angle, angle. So they have all three corresponding angles are equal. So this angle here corresponds to this angle and it's equal. This angle corresponds to this angle and it's equal. And obviously then this one and this one must be equal as well. So you can just have two corresponding angles, and you can say that those triangles are similar, because if two corresponding angles are equal, obviously the third must be equal as well. We can also have the right angle, hypotenuse and side test as well. So in this test, the hypotenuse of right-angled triangles and another corresponding pair of sides are in the same ratio. So in this one, the hypotenuse is 5, and this one it's 15, so it's 3 times as big, the one on the right. And on this one, this side's 2, and this side is 6. Again, it's 3 times as big, and they both have a right angle. So the corresponding sides are of the same ratio, and they both have a right angle. So there we know. From there, we know they're similar triangles. So we're going to do a few worked examples about this. Okay, so worked examples: identify the similarity test which proves each set of triangles are similar. So for A, you can see there we actually have corresponding angles. So this angle corresponds to this one and it's equal. This one to this one is equal. This one to this one. So there you go. For A, it would be angle, angle, angle. That proves that they're equal. For B, so in B, the hypotenuse here is 9 and the hypotenuse here is 3. So if we did 9 over 3, that's 3 over 1. Then we've got 6 and 2, so 6 over 2, that equals 3 over 1. So again, those sides are in the same ratio and they both have a right angle. So that would be right angle, hypotenuse, and a side all being equal. For C, we have corresponding angles that are equal, and then we're looking at the sides here, so the ratio of the sides. So this one is 6, and this one is 18, so the one on the right is 3 times as big. This one's 7, 21, 3 times as big, so we have side, angle, side, making them similar figures there. And our last one, which you could probably guess what our test is going to be, but we'll go over it anyway. So if we look at corresponding sides, so this is our longest one here, and this is our longest side here. So that's 5 over 15, so that's 1 over 3. Next side, our next longest side is this one here and this one here. So that's 4 over 12, 1 over 3. And if we test our last side, which is our shortest, it's 2 and 6, so 2 over 6, that's 1 over 3. So again, they're all in the same ratio, so it's just side, side, side. So they're the tests that we'd use for that one there. Okay, so worked example time. So use the diagram below to answer the following questions. So A, give a reason: side, 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 angle, 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 or right angle, hypotenuse, side, why the two triangles are similar. Okay, so looking at this one here, we've got one larger triangle, so we've got a triangle which is ACE, and we've got a triangle there which is BCD. So hopefully you can see the two triangles there. So what we're going to do is we're going to work out whether these triangles are similar. Okay, so the first thing that we can do when we're looking at this is work out if we have any similar angles, which we do. So obviously this angle here is going to be common to both of them. So our angle, what is that? ACE equals the angle BCD. It's common to both. So we have this angle here that's going to be common to both. So we could also look further and see if we have any other common angles at all. And we can see that we do. So this angle here and this angle here would also be common to both because these lines, so the line AE is parallel to BD, so therefore the angle from EAC is going to be equal to the angle from DBC. So now we've got two equal angles, and therefore we give the angle test because that test says only two of the angles need to be the same in the triangles, and obviously then the third will be the same as well. So therefore the triangles satisfy the angle test. And that would be my answer there for A. So for B, we have to find the value of X. Okay, so I'm going to clear my screen and do B. So obviously they're going to be in the same ratio. So it doesn't really tell us here which one's the original and which one is the image. So we know our scale factor is our image over our original. So we are given two sides here. So the 2 and the 3 side, they're corresponding sides. So I can let either one be the original. I'm going to assume that, oh, I don't know which one is. Okay, so let's just say 3 is our image and 2 is our original. So 3 divided by 2 is going to give me 1.5. Okay, so from there I can work out my value of X. So X is the longest side of that image triangle, which is 1.5 times bigger than the smaller triangle, which is 5 centimeters from here to here. So it's going to be 5 times 1.5. So the distance of the corresponding side, which is D to C, is 5 centimeters. We want to find the distance of the side E to C, which is 1.5 times bigger. So it's 5 times 1.5, not 1.15. Which is 7.5. So we know there then our longer side is 7.5 centimeters. Okay, so to prove that triangles are similar, list any pairs of corresponding equal angles or pairs of sides in a given ratio. So give reasons at each step. So if you're saying these two are equal or these two are the same, you have to tell me why. So why are they the same? So give the reasons. So just like I did before in the previous one, saying, they share that angle, that's a reason why. Then you can write your similarity statement. So for instance, triangle ABC is similar to triangle DEF, or you can use a different symbol. And then you write this triangle similarity test in the abbreviated form. So which test did you use to prove that they were similar triangles? And to apply the similarity in practical problems, there's some steps that you have to follow. So first, prove the triangles are similar. Second, find the scale factor. And the third one is to find the value of any unknown. So you have to do it in that order, otherwise it won't work. So there's no point finding the scale factor if they're not similar triangles. So first you have to prove they're similar. Once you know they're similar, you can calculate your scale factor. Once you know your scale factor, you can then find the value of any unknown. So you have to do those steps in order. Okay, so let's do some worked examples here. So prove that each pair of triangles is similar. So you can see here, we've got a triangle here, so that's ABC is one triangle, and then a smaller triangle here, which is DCE. And we have to prove that these triangles are equal. So we are not given any side length, so obviously we know we can't do anything with that. So we're going to be looking at angles. So starting from this, you might see some parallel lines. Well, you will see some parallel lines. So you see that A and B are parallel to D and E. And we also have a line cutting the two parallel lines there. So hopefully that will start you thinking there. So remember, parallel lines that are cut by a transversal, so a line like that, so anything that cuts those parallel lines, so anything that cuts a transversal line will create a set of corresponding equal alternative angles. So, for instance, something like this, so we've got, just draw it so it's a bit more clear here. This is A, this is B, D, E. We've got parallel lines, so A and B are parallel to D and E, and they're being cut by that transversal, so that's going to create a pair of alternative equal angles. So this angle here is going to be equal to this angle here. So we can actually write that here. So our angle ABC is equal to, I'm drawing on my face, I'm sure, our angle of C, D, and E, because AB is parallel to DE and parallel lines cut by a transversal create a pair of equal alternative angles. That's terrible writing. I will try to be a bit neater. Okay, so then the opposite, if we look at, I'm going to change my pen color, we can also see here, we've got the same kind of thing going on here. So if I was to draw that, we've still got this line and this line being parallel. This is B, this is A, this is E, and this is D. This angle here is going to be equal to this angle here. So our angle BAE is going to be equal to our angle, oh, we've got C here in the middle. It's going to be equal to our angle of CED. And again, it's the same rule because we've got those parallel lines being cut by the transversal, and they're creating a pair of equal alternative angles. So again, I'm going to be very neat now, because AB is parallel to DE and parallel lines cut by a transversal create a pair of equal alternative angles. Okay, so now on our triangle we have this angle here and this angle here are the same, and we also have this angle here and this angle here being the same. We've satisfied the rule AAA. So obviously you'd write down the page. I once again have run out of space, so I'm going to have to clear the page, but hopefully you can see that there. So I'm going to write our answer in words. So therefore, triangle ABC is similar to triangle now I've forgotten where my angles were. So that one was there, that corresponded to that angle. So what's that? C, D, E. Anyway, that might not be in the right order. It's triangle DE as it satisfies the angle test. There we go. Okay, for our second one, I'm going to clear the screen so I've got a bit more room. So B, we'll work that one out. So we've got to prove that those two triangles are equal. Okay, so we're going to prove that triangle. So we've got a triangle that is AEC and a triangle that is DBC. So we're going to prove that they are equal. So we're given, this time we are given side lengths, so we can actually use those side lengths to prove that the triangles are similar. Okay, so if we start off, we can try and find which sides are corresponding. So obviously our largest side here is A to C, and on our smaller triangle, if we look at it, our largest side is going to be D to C. So we'll see if we've got the ratio there. So the side ratio, A to C over D to C, so that's 18 over 6 equals 3 over 1 equals 3. We've also given another side for both of them. So in our larger triangle, we're also given E to C, and in our smaller triangle, that corresponds with B to C. So that's 12 over 4, which is 3 over 1, which equals 3. So we can see there that the sides are corresponding. So we've got side corresponding. And the last thing that we've actually got here is they actually have an angle in common. So angle ECA is equal to angle DCB, as it is a shared angle. So now we've got a side in common, another side in common, and in between those two sides we've got an angle. So therefore triangle AEC is similar to our triangle DCB, as it satisfies, spelled that wrong. So it satisfies the side angle side test. There we go. It's as simple as that. And that's all I've got in today's video. If you have any questions at all, please make sure you ask them in class.